Question 11. A stationary truck at rest emits a constant tone of 400 Hz from a loudspeaker attached to its roof. A person is walking along a straight road, 50 meters away from the truck, at a constant speed of 2 meters per second. Toward the truck, the speed of sound in air is 343 meters per second. Calculate the frequency of the sound as heard by the person. Now this is a problem relating to the Doppler effect. What we already know about the Doppler effect. We know that the Doppler effect describes the observed change in frequency of sound when there is relative motion between a source and an observer. The Doppler effect only changes the frequency heard, not the actual frequency emitted by the source. When the observer moves toward a stationary source, the observed frequency increases. For a moving observer and a stationary source, the Doppler formula is given by F. Observed frequency equals original frequency multiplied by the quantity, speed of sound plus observer speed, divided by speed of sound. The case of a moving observer and a stationary source is very rarely tested in the curriculum, but this problem should give you an exposure on the formula and some experience in dealing with this case. Now let us think through the solution, step by step. The emitted frequency is 400 Hz. The speed of sound in air is 343 meters per second. The observer's speed toward the source is 2 meters per second. Because the observer is approaching the source, we use the Doppler relation with a plus sign in the numerator. So, the observed frequency equals 400 multiplied by the quantity, 343 plus 2, divided by 343. Next, we simplify the expression. 343 plus 2 equals 345. So, the expression becomes 400 multiplied by 345 divided by 343. Evaluating this gives an observed frequency of approximately 402 Hz. So, the sound heard by the person has a frequency of about 402 Hz. This is our final answer. What did we do? First, we recognized that the problem involves the Doppler effect, with a moving observer and a stationary source. Next, we selected the correct Doppler equation for a moving observer. Then, we substituted the given values for the frequency, speed of sound, and observer speed, and simplified the expression to obtain the observed frequency. Here are a few tips on this problem. When applying the general Doppler formula, remember the sign rules. If the observer moves toward the source, the observer speed is added in the numerator. If the source moves toward the observer, the source speed is subtracted in the denominator. This is the most general formula for the Doppler effect that includes all cases. If either the source or the observer is stationary, their corresponding speeds, v sub s or v sub o, is assigned a value of 0. Also remember that distance does not affect the Doppler frequency shift. The observed frequency depends only on the relative velocity between the source and the observer, not on how far apart they are. Let us summarize at this point. For a moving observer and stationary source, the observed frequency increases when the observer approaches the source. Direction matters. Approaching corresponds to a plus sign in the numerator, while receding corresponds to a minus sign. The Doppler effect depends on relative velocity along the direction of motion, not the separation distance between the source and the observer.